Introduction. For thousands upon thousands of years, humanity has lifted its gaze to the night sky, and wondered, what is the moon? Why does it shine so softly, yet so powerfully? And why does it seem to follow us, across the vast deserts of Africa, over the endless Pacific Ocean, through ancient forests, and into the imagination of every civilization on Earth? The moon has been our guide, our calendar, our companion, and sometimes, our mystery. Tonight, we embark on a journey not just across distance, but through time, 4.53 billion years of cosmic history. We will step back into the early solar system, walk across ancient lunar plains, explore its hidden interior, and uncover secrets that even today challenge our scientific understanding. This is the story of the moon, ancient, luminous, and forever bound to Earth. The birth of the moon. Picture the early solar system, violent, unpredictable, filled with newborn worlds colliding and reforming. Earth, only 30 million years old, was still a molten sphere of magma, its surface hotter than lava lakes we see on Earth today. Then came the impact that changed everything. A Mars-sized body, named Theia, collided with Earth at a speed estimated between 24,000 and 40,000 kilometers per hour. The force of this collision released more energy than 10 billion nuclear bombs. Rock vaporized instantly. Entire sections of Earth's crust were torn away and thrown into orbit. This glowing cloud of debris, millions of tons of molten and vaporized rock, began to circle Earth. Within a few months to a few years, gravity pulled the fragments together, forming a molten sphere, the earliest moon. Evidence supporting this dramatic event includes isotopic fingerprints of Earth and moon rocks are nearly identical, suggesting a common origin. The moon's density is only 3.34 grams per cc, far lower than Earth's 5.51 grams per cc, showing it has a much smaller iron core. Lunar samples from the Apollo missions contain anomalous levels of volatile depletion, consistent with formation under extreme heat. From a catastrophic collision, came the companion that would shape Earth's destiny. What the moon is made of. The moon's interior tells a story of fire, cooling, and unimaginable time. The core, radius, 300 to 500 kilometers. Mass fraction, approximately 1.5% of total lunar mass. Composition, iron, sulfur, nickel. Temperature, estimated 1,300 to 1,900 degrees Celsius. Though partially molten, it is far smaller and cooler than Earth's core. The mantle, thickness, approximately 1,300 kilometers. Once filled with magma oceans, responsible for volcanic activity that created the Maria. Geological evidence shows that major volcanic eruptions occurred between 4.0 and 1.2 billion years ago. The crust, thickness, 30 to 50 kilometers, thicker on the far side. Composed mostly of anorthosite, rich in aluminium, contains the oldest surface material ever observed. Some fragments are over 4.36 billion years old. Because the moon lacks an atmosphere, no wind, no rain, no flowing water, crater marks remain perfectly preserved. A single footprint from Apollo 11 could remain visible for at least 10 million years. The landscapes of a silent world. From afar, the moon looks simple, patches of light and dark across a grey canvas. Up close, it is a world of astonishing variety shaped by time, violence, and silence. Maria, the seas, cover 16% of the lunar surface, formed by massive basaltic lava flows. The largest, Oceanus Procellarum, spans 2,500 kilometers. Early astronomers believed these were oceans, inspiring the name Maria, Latin for seas. Craters and impact basins. The moon has more than 300,000 craters over 1 kilometer across. Some ancient impacts reshaped entire regions. Tycho 85 kilometers wide, with rays stretching over 1,500 kilometers. Copernicus 93 kilometers wide, a masterpiece of lunar geology. South Pole Aitken Basin, one of the largest impact craters in the solar system, 2,500 kilometers wide and 13 kilometers deep. Highlands, the ancient mountains. These bright, elevated regions formed over 4 billion years ago, making them some of the oldest surfaces visible from Earth. Regolith, the lunar dust. Thickness, 3 to 5 meters in Maria, 10 to 15 meters in Highlands. Created by countless micrometeorites. Contains sharp glass fragments formed by heat from impacts. This dust is so fine yet sharp-edged that it clung stubbornly to Apollo astronaut suits, so abrasive it damaged seals and tools. The moon is silent, untouched, and frozen in time. The dance between Earth and moon. The moon's motion is a cosmic choreography billions of years in the making. It orbits Earth every 27.32 days, and rotates at the same speed. This perfect synchronization, called tidal locking, is why one side of the moon always faces Earth. Distances shift slightly. Perigee, closest point, approximately 356,500 kilometers. Apogee, farthest point, approximately 406,700 kilometers. This variation creates supermoons, when the full moon appears up to 14% larger and 30% brighter than usual. The moon is also slowly drifting away at 3.8 centimeters per year, confirmed by laser reflectors placed by Apollo astronauts. At this rate, in 600 million years, total solar eclipses will no longer be possible. Earth and moon will no longer align perfectly. How the moon shapes life on Earth. The moon is not merely a companion, it is an architect of Earth's habitability. Tides. The moon's gravity creates tidal forces that shape coastlines, regulate sea life, and influence global climate cycles. Without the moon, tides would be two-thirds weaker, severely impacting marine ecosystems. Stabilizing Earth's tilt. Earth currently tilts at 23.5 degrees, creating seasons. Without the moon, simulations show Earth's tilt could shift wildly from 0 degrees to 85 degrees over millions of years, causing catastrophic climate swings. Slowing Earth's rotation. Billions of years ago, a day lasted only 6 hours. Tidal friction caused by the moon has gradually lengthened Earth's rotation to 24 hours today. This process continues. Days grow longer by about 1.7 milliseconds per century. The moon shapes our oceans, our seasons, our climate, and even the length of a day. It has guided Earth's evolution, quietly, constantly, faithfully. The moon in human culture. No celestial object has lived more deeply in the human imagination than the moon. For tens of thousands of years, ancient people carved its cycle into stone, creating some of the first calendars. The Babylonians, Egyptians, Greeks, Chinese, and Maya all built their timekeeping systems around the moon. Myths arose. Khonsu, the Egyptian moon god. Selene and Artemis in Greek tradition. Chang, the moon goddess of China. The man on the moon in countless cultures. Kwa and the banyan tree in Vietnam. The moon inspired poetry from Homer to Shakespeare, music from Debussy's Clair de Lune, and countless works of art. To humanity, the moon has been a symbol of longing, love, mystery, and wonder. The race to the moon. In the 1960s, the moon became the stage for one of humanity's greatest achievements. Apollo 11, Neil Armstrong stepped onto the lunar surface, followed by Buzz Aldrin, while Michael Collins orbited above. The missions that followed, Apollo 12 through Apollo 17, brought home 382 kilograms of lunar samples, including ancient anorthosites and volcanic basalts older than any rock found on Earth. Apollo data revealed evidence of a molten lunar past, magnetism suggesting a once active core, rare isotopes helping refine the moon's age to 4.53 billion years. The footprints left there remain untouched, preserved in silence for millions of years. Hidden secrets of the moon. But the moon still guards many mysteries. Water ice. NASA's LCROSS mission in 2009 detected water ice in the moon's south polar craters, possibly hundreds of millions of tons. The far side. The far side is completely different. Thicker crust, fewer maria, more rugged topography. China's Chang'e 4 mission in 2019 was the first to land there, revealing rocks from deep beneath the surface. Moonquakes. The moon experiences quakes up to 5.5 on the Richter scale, lasting up to 10 minutes, due to tidal stresses and temperature changes. The moon may be silent, but it is not dead, it still breathes in geological whispers. The future of the moon, extended. We now stand at the dawn of a new lunar era. NASA's Artemis program plans to return humans to the moon by the mid-2020s. Its goals include building the Artemis base camp at the South Pole, extracting ice to produce oxygen and hydrogen fuel, establishing Gateway, a lunar orbiting station that will support missions to Mars. Other nations are joining. China plans an international lunar research station by 2035. India's Chandrayaan missions continue mapping lunar water. European robotic missions prepare for long-term exploration. Within the next 20 to 30 years, the moon may host permanent habitats, scientific observatories, mining operations, refueling stations for deep space travel, the first extraterrestrial communities of human history. The moon is not simply a sphere of rock orbiting Earth. It is Earth's memory, its silent witness, its cosmic partner. It has shaped our tides, our seasons, our days, our climate, our myths, our science, and our dreams. When you look at the moon, remember, its gentle glow comes from a world born in fire, carved by time, and preserved by silence. A world that has watched Earth change from lava oceans, to continents, to civilizations, to the people we are today. Our journey to understand the moon is far from over. In truth, it has only just begun.